Hello, welcome everyone to Quality Management and Applied Statistics. My name is Ulrich Weber and this is the second lecture on statistics. Today we're going to talk about probabilities because last time we just looked at how to analyze data. If we want to go further and think about probability models that produce the data that we saw, for example, we have to learn about probabilities first. So this is our first topic for today. Okay, so how does it work with probabilities? So a simple approach is the following. So if you wanted to know what is the probability of rolling a 6 with a fair die, we could say, okay, there's like 6 different outcomes and this one here, the 6, that's our favorable one. But in total there's 1, 2, 3, 4, 5, 6 different outcomes. So probability is like one favorable one divided by all the outcomes. 1/6. If we write it a bit more general, so we can say if all outcomes are equally likely, then the probability of an event A is the number of favorable outcomes for that event, all the favorable outcomes, divided by all outcomes that are possible. If I put this in a formula, we could say the probability of A is cardinality of A divided by cardinality of omega. Later on, we're going to see that we can generalize that, and we can get rid of the condition that all outcomes have to be equally likely. We can turn it into a sum over the probability of each outcome, but about that later more. I've already introduced a few symbols here, so let's talk about it. So P of something, that always stands for probability. It's basically a number between 0 and 1, where 0 means it's impossible, it will never happen, and 1 means it certainly happens, it definitely happens. The Greek letter, the capital letter omega, you've probably seen that one before, that is the set of all possible outcomes, everything that can happen in our sample universe, so it's called the sample space. And if we're talking about events, an event A always contains a set of outcomes. So for sets we use these curly brackets, and we can write inside like all the outcomes that can happen. So for example, earlier we wanted a 6, didn't we? So this would be our event A for that. So then we can say probability of this event A, and we've calculated that, that's 1/6. Here the cardinality, those vertical lines, means like number of elements, how many elements are in our set. Okay, so these are just the basics to get us warmed up. Let's look at some exercises. So we've got this old-fashioned computer, and it produces a number of digits, 4 random digits between 1 and 4. And what are the chances of obtaining the sequence 1, 2, 3, 4? You can pause here, and then I'll show you the answer. Yes, of course. 1 to the 4 to the power 4. So if you have, let's explain it. We've got the choice between 4 numbers, 1, 2, 3, 4, and we're producing 4 of those. So our sample space is 4 to the 4, or 265, 56. We want a certain outcome. We want exactly 1, 2, 3, 4. So I'll make that green. So the number of outcomes of event A, so our event A basically is 1, 2, 3, 4, this one element here. So that means there's only one outcome that's favorable to us, and there is 256 outcomes possible. So that gives us 0.4% roughly. Okay, can you see where I'm coming from? Let's try another one. Let's make it a bit more complicated. So we've got 2 dice. Obviously 6-sided dice, 36 possible outcomes. What's the probability for an outcome that sums up to 5? Exactly 1/9. How do we know? Well, we can just count. So we can sum up to 5 with a 1 and 4, or with a 2 and 3, or the mirrored ones, 3, 2 and 4, 1. So there's 4 possible outcomes, 4 outcomes that are favorable, and in total we said 36. So cardinality of omega is 36. 4 over 36 gives us roughly 11% chance. One last one. What's the probability for an outcome with a sum 4, or both dice showing the same number? You probably have to pause a bit longer and think about it. Yes, exactly 8 over 36. We could just write them all down again. So these ones here, they all sum up to 4, and then these have the same number. So that's 8 in total, 8 favorable outcomes out of 36. But isn't there a better way of getting this? Couldn't we, we've got this or here. Couldn't we say, okay, sum equals 4 is like an event A, and both dies showing the same number, that's an event B, and then we just calculate them separately and kind of add them up. And the answer is there is a way to do it like that, and that's the reason why we have to talk about sets if you want to talk about probabilities as well. More about that in the next video.